in the construction phase. You can use the same model, for example, to calculate, and we've done in a couple of projects, to optimize the crane laydown time. So there are the cranes are modeled in here. They show at what point of time any crane is active if the construction is happening in a virtual environment. And you can then see a crane would be inactive for about few days. So you can change the sequence of your construction, and then your crane would be optimized. So this way we have optimized almost 30% of crane deployment on project, which helps you save money. Or analyzing existing services in the project, preparing the current site accesses, finding the flaw in the logic, or even phasing the project in a timed manner where you can get time and cost dimension to the project in a real time. I'll show the video as well. The same model then moves into facility management model, where you can actually link it to a facility management system. And as I explained, you can get a full building maintenance schedule. You can have building system analysis. You can do your asset management. You can do space management and tracking. You can do disaster planning. You can do record modeling. And this record modeling, in a lot of countries, reduces the insurance premium which you have to put for your building, because your entire asset is accurately digitized. So any time down the line, you can use the project to upgrade it, maintain it, and often with many assets, you have to kind of you have to upgrade the asset, and that point of time you don't get the information which was available. Here the information would be live. I'll skip this slide. So this is one small video which will show a typical 4D sequence. We did for a school in UK. It'll show you how at any point of time you can link a full 3D model with a time schedule. I wanted to actually show a different video which is not running, so we've put this one. You'll see a time phase pattern going below. So at any point of time in the project, we can plan what action will happen at that point of time. And this is just a video, but it's in a real time, it's a full analytical model which you can run on. So for any date, you can see what is going to happen at that point of time, what kind of cost impact, what kind of labor deployment, what kind of equipment on site is available or is needed to do that. And that helps you optimize your construction program completely. So it's demolishing the areas, how to bring up areas, and once you do this complete sequence, you see how you can do effectively the same construction which until unless you bring it to a schedule doesn't really make clarity in your working environment. So you'll see the new building has come up, the landscaping will come up. So I'm not showing the detail of this coming in. While the detail thing runs in, it shows every single detail of, at that point of time, what is the amount of labor on site, what is the construction material being used, what is the cost of the project, how much is the crane deployment happening. That comes on a matrix on the left side. It was not running, so I had to use a substitute video for the moment. Can we go to the next? Yeah. This slide actually explains how this process of integrated project delivery has changed the way we design the projects. So until now, typically in a project, how the things would be, all the stakeholders, right from architect, mechanical, electrical, fire, civil, will do his own work. They will prepare drawings, and those drawings would be put in tender, which will never be coordinated. But instead of that, using this technology, we can have a single line diagram, and from there we directly get into the model. And from model, we get the information out, which is so detailed that the fabrication can be done. This is another case study of a hotel project where we we prefabricated the entire central riser of the hotel. The central riser of a hotel is one of the complex place where all pipes and all services come in. And by doing this, we actually saved about 4% of the pipe run, 2,000 meter of pipe, which otherwise is not possible without doing an integrated manner. I'll show a video of this and instead of going through this one. Can we run the video? So this is a project we did about 5-6 months back. So if you see from an existing 2D information, we're getting into a 3D BIM model, integrating all the services together. This is the central riser, and these slabs are getting cast. These are the toilets, which are also modularized and standardized. And from there, we took this model directly to off-site fabrication with a contractor called Leighton. So the same thing, if you'll see, they have manufactured from our computer output on in a lab environment, a full riser floor to floor, which is fully integrated, optimized, and this can come at any point of time with minimal labor. Traditionally, this would take about a few weeks to do on site, but with this method, it takes just about 2 minutes to set this up into one floor to another floor, you'll see. Can you increase the volume? There's a sound. No, not coming. You'll see the structural framework is also already been done. And this is actually happening in India. So this was the first time in India that we did a fully fabricated, off-site manufactured, complicated building component done in BIM and 3D environment. It doesn't depend on program of your schedule. These standard modules can be brought on site and erected in a short while. The site is in Gurgaon, one of the premium residential projects called Camellias, where this is going on. So from days to minutes, you'll see just how quickly the installation would happen with the couplings. So there are two options to this installation, for example. One is with the entire wall, core and everything coming in and getting fixed at the site. The other is if the core is already done, you can bring the bare frame integrated pipe system, which will get into the core which you've already done. So this is just one example of how making your entire system in a virtual environment with all the information tagged onto it, analyzing on cloud, and then taking it out to a factory environment, saving on any defect or any optimization which would have been not possible otherwise, and then bringing onto site as if you are assembling the computer rather than making a building. We've done standardization of this sort for even the level of toilets, full assembly of walls, full assembly of small rooms, which could be then done off-site. So you get a coordinated design, you save safety, you save cost and time. So these are the kind of benefits you get around using integrated project delivery on BIM. Thank you for the moment. Any questions?
Thank you very much, Mr.
Thank you.
Shangari. Ladies and gentlemen, any questions for Mr. Shangari? Yes, there is a hand raising there. Could I have the mic moving there, please?
First of all, this is wonderful. I've never seen anything like this before. I just have a few questions. So in essence, we're trying to model the structure in 3 dimensions, whichever structure we're going to be building. I just had a few queries on whether, does it cater to shell structures as well? What about earthquake simulations? And if you actually want to do the analysis of a particular frame, does it have the capability to do it, or it is only at an architectural level? And what platform did we use to build this package?
Thank you. I'm glad you kind of like this thing because it was our first attempt to kind of do in India. We've been doing this abroad for a long time. So to answer the questions, yes, this is, first, this is not a pure 3D model. The model is full of information and can be analyzed. Second, the full structural analysis can be done for any structure, whether it's a shell structure, whether it's a draft chimney, or whether it's a machine foundation for a nuclear plant. You can do any analysis on this one. The important thing is, in building information model, it is not a software-driven approach. You have information which is software independent. They are done on IFC protocols. So there are different softwares. There are about 10 to 15 different softwares where you can interpolate information, as you saw in my bubble method, to link everything with each other and analyze it. So for example, in the case study we showed you, we use primarily Autodesk products. The Autodesk product, Revit, Autodesk MEP, some level of Tekla, and a little bit of Bentley products. But there are 4 or 5 different companies like Bentley, Autodesk, Dassault, Intergraph, which are into this business, and they have different softwares which do different type of analysis. Apart from structure, you can do analysis, a full analysis of even a duct, a full pump design, a full velocity calculation, full simulation of environment within the building as well. So right, electrical, mechanical, structural, architectural, energy analysis, everything you can do on these softwares. And what was your last one? Have I answered each one of them? Earthquake, yes, you can do a full earthquake analysis as well, using the same model, because you typically would do, you can export the same data into STAD, GTStrudel, any of those existing softwares, or ETABS, and they are interlinked and talk to each other. Yeah.
Sure. Material to building through information. Sorry, somebody has raised the hand and asked.
I had a question here. Well, you have mentioned that this is helping us in the construction phase. How do you address the ongoing requirements after the construction is completed? So say, for example, you have a 25 floors tower ready and you have delivered it out. But now going forward, in the eventual future, there might be some breaks. So at that time, have you all foreseen that? How you all plan to support that? Or is that something an afterthought?
I didn't get your question. Can you come again, please? A bit louder.
Okay. So say, for example, you have this plumbing framework, which is patented, and you all are doing it in an offsite. So in the construction phase, it's helping them, which makes sense. But after the project is completed and delivered, okay, so suppose if I am a person who constructed that and I have to maintain it.
Mm-hmm.
So since this is an integrated form of a plumbing, there could be some wear and tear, some damage.
No.
How do I go ahead and address that? It's an afterthought. It may not be directly related to this.
Yeah, let me understand your question clearly once again. You're saying, taking one of the examples, if we've already done this integrated riser shaft and installed on site, how will I maintain it and operate it later down the line?
Yeah.
You will maintain and operate it exactly the way you do in a traditional project, because this is modeled as if the building is modeled in modular, standard, broken down forms. So the only difference is probably this entire building would have been made with the biggest component would have been a marble plate or a brickwork. In this case, we will get a full panel of wall, a full corridor, but with vents, with doors, with service shifts, everything coming out in the same way as a traditional building will work. So there will be nothing different from a traditional building. The only thing is the construction would be done in an integrated manner in a factory environment, using automated machines rather than on-site. What somebody comes in, he just puts his thing there and goes away. You find later down the line there is no space. Piping comes and puts something else. Cable tray comes and puts something else. So that is a very tedious and very cumbersome method. In terms of operation and maintenance, there will be no difference. In fact, it will be better because we would have visualized all operation maintenance problems in the model itself while doing a walkthrough.
So will they need some form of an infrastructure?
You need for different level of component manufacturing, you need different level of infrastructure. You're saying infrastructure to produce this kind of a...
I'm talking about the after delivery part.
No, after delivery, you don't need anything. See, there are 2 types of operation and maintenance you'll have to do. One, physically going and actually doing an operation and maintenance for the building, which will remain the same way. You will go to any part of your asset, open it, change the wall, break it, change it the way. The difference which I was telling in terms of automating your facility management is you will have an option of automating your facility operation and maintenance with a computer system where you can just sit on a system and say at any point of time, today for example, how much my building is consuming power, what is the daylight which is coming into my building, what kind of heat exchangers are running right now, and it gives a real-time data. So you can analyze that data using this model and optimize and then go on site and work on it.
Perfect. So just to add to the last bit of it, say for example, during the maintenance period, okay, so let's take an example, you have a 25-story tower, and if floor number 11 has got some wear and tear, and that needs to be replaced, how do you address that? They cannot just, like pull that piece out?
You have a 25-story tower.
Okay, so
Yes.
you have gone with this integrated construction. So say on floor number 11, somewhere in between,
There'll be
there's some
ledge.
wear
So
and tear.
wherever the problem is, there'll be a service door at every level, there'll be a ledge, there is an integrated door into it as well, if you saw that. So
Okay.
this
So
is
each
done.
piece could be individually fixed.
What I can tell you, each piece is not fixed like that. If you look at every floor, the fitting of every single element is done the way it would be done in a non-integrated environment, in the
Okay.
traditional way. The difference is this has been done in a time which is ahead of it,
Perfect.
in
Right.
a factory controlled environment, which is easier to actually maintain and install. So it is not that a pipeline will run from ground to top. It will have the same kind of couplers, same length, 6-meter lengths. You can do smaller or bigger depending on maintenance schedule. So it's not going to be different from the way it is traditionally constructed, but it's done in a factory environment.
Oh, sure.
That's the only
Thanks.
difference.
We have Dr. Rastogi lifting the hand here. We'll just take that last question and we'll close the session.
Yeah, this BIM concept is really excellent and has brought lots of revolution in construction industry. My background has been mainly in manufacturing earlier, so I see it's similar to what we had, the 3D modeling and prototyping in manufacturing assemblies and all that. So at least it's come in construction. So my question is related to what we did in manufacturing earlier, because construction is learning lots of things from manufacturing.
It is actually getting derived from
Yeah.
that, yes.
So earlier we had a CAD system, 3D modeling system, and then it was finally integrated with SIM, computer integrated manufacturing. So my
Yes.
question number one is whether BIM is integrated with the manufacturing in some way.
It is. In fact, the kind of manufacturing which you see happening, a lot of projects currently we are working out from our ThinkBIM company in India is very different from what we used to work earlier. We do a full 3D detailed model of every component, even a column, for example, which has been 3D printed in UK with companies using complete CAFD environment, and you get a ASCII file which goes into any of these NEMECEX.
Basically, is there no human intervention? That is the
No
meaning
human
of it.
interference. So there are just robotic labs where you can put the entire BIM model into the robotic labs. They cut, bend, tag, and three of the factories which I have visited myself where we have done this. One of them is in central London, UK. Our model completely goes to the factory. Factory reads the machines read the entire model, and they start fabricating entire components without human interference. And because of that, the quality increases, and because of that, you even save every single wastage you would do on a typical length of a rebar or a pipe or anything.
So one last question is little futuristic. Is it also in some way being thought in for future modeling is linked with 3D printing?
It is. In two of our projects, in fact, we've done the next wave in BIM is going to be 3D printing itself. So for example, we have done a full detail output of a project. The project is, say, in Alaska. And you find out while installing there are 2 screws missing. And we have done that way. So we've just sent the information of those two screws on site, and with a small 3D printer, you've just printed a screw there and installed immediately, without having to run through a whole hassle of ordering it again. And this is happening. This is happening real time.
Very good. I'd like
Thank
to
you.
connect to you later.
Yeah, we'll do.
Thank you.
Thank you.